Hi everyone, and today I'm pleased to show you a tech demo with AgentJo. So, recently people have been asking me, hey, could you do something practical with AgentJo? So here's a showcase of how to do something related in FinTech with AgentJo. So first step, we just import AgentJo like this. Put in your OpenAI key here, API key. You can also use other LLMs, it doesn't matter. As long as you define your own LLM that takes in the system prompt and a user prompt, and then you put your own LLM over here and just return a string. All right, that's all you need to do. Here we use GPT-4o mini from OpenAI, and you can just test your LLM by just making sure that it outputs something if you run the LLM call. All right, so first we have StrictJSON. So StrictJSON basically is an LLM parser that outputs in JSON format that is like about half the tokens of Pydantic. All right, so even less if you have a longer output format. So here I have a text from MAS. So you can see this is MAS over here. This is one of the news about a new expansion. All right, and this basically we can put in the text here. Of course, you can also do web scraping, but I put the text here right now. So we can ask StrictJSON to just summarize and give the sentiment of the text, maybe even come up with like who are the people involved and so on. So you can see the summary. FinTech network established is a positive sentiment. Yep. Then these are the people in the article, and these are the corporations. And you can easily get your stuff out like that. So StrictJSON is very easy to pass out stuff in your desired output format. You can even put your desired types here. For more information, you can go to the AgentJo GitHub. It's stated there. So yep, so that's basically StrictJSON. So you can also do like chat with PDF and stuff like this. So we have an inbuilt memory here. We can just add a file, and basically you can set how much top K you want, which is you retrieve 3 different sources at one time. And we can see that these are the different chunks over here. Back end, we actually use the LangChain text splitter to just split the text up, but you can use whatever you want to split the text, and you can put your own memory yourself if you want to as well. So next up, we can then say that how many transactions did this global payments industry handle in 2023? So right now, you have to give it some time to do the embeddings because this is the first time we are retrieving the text. So you can see that this is the PDF. In order to download this, you can actually go over to the this link here, and this link will give you the place to download the PDF. All right. So this PDF here, once you look at it, there's a lot of pages, like 17 pages, and the answer for this question is, I think it's 3.2%, 3.4%, I think. Yeah, I can't remember which page it was from. Here we go. Yeah, 3.4 million transactions. So let's just run this and then see whether it can answer the question. So yeah, give it a while. This part is not optimized yet. Of course, if you want to make it quicker, you can just use one of the ready-made databases like Llama Index and so on. So yeah, let's just give it a while for it to load. There we go. So these are the chunks that it retrieved when you ask it the question, how many transactions did the global payments industry handle in 2023? So you can see I've now labeled all my sources 1, 2, 3. I can run a StrictJSON call to say that, hey, write me an answer and cite the sources according to the number. And you can see it cited sources 1 and 2. So cool. Now let's use an agent to do this. So here, the agent, we just define a function, get knowledge, put in your input variables here with your types and the output types here, put in a doc string here that talks about what the function is doing, and put in the variable name inside here. So that is very cool, magic, because AgentJo will automatically pass the variable with angle brackets so that the agent will know what are the variables to fill in. So here we retrieve from the memory, we retrieve top K based on the query. Then we use the StrictJSON call that we saw earlier to write out the answer in the form like of this with the cited sources. So you can see that if we run this, we can get the answer and the sources. So we define our agent question answerer that answers questions factually based on the retrieved knowledge, split the query into multiple parts and query separately. We do not use the default LLM function because we don't want it to hallucinate information. We just want it to only use the get knowledge function. So this LLM function is in case you have an agent that needs to generate new things, the LLM function can help it to generate, but this is not needed in this case. Define our LLM from OpenAI earlier, assign the functions get knowledge to it. So we do it. You can see these are the functions right now. We have get knowledge. The description is retrieve relevant information according to query string. So we automatically pass this into a form that is readable by the LLM. And if you take note, like compared to how Pydantic does this is at least 2 times fewer tokens. So yeah, I created AgentJo basically because I didn't quite like Pydantic. I wanted a more concise representation of how to do the JSON format. All right, so we can run this. What is the number of transactions of the global payments industry handled in 2025? And yeah, we can see, okay, so this 2025 here, you can see it is right now, it grew 2023. So it is projected to be 3.4 trillion based on 2023 data. So you can see this, we reply in this format. Yeah, so they basically projected it will be 3.4 trillion in 2025 because of the 2023 data. Actually, I think over here, there's only 2023 data. So you can just run this again. So at least with the sources, you can see like, hey, where did the LM get the information from? So you won't be like too shocked. So one thing I like about the citation is that it helps to validate the LM answer. So yeah. Okay, so yeah, more work needs to be done on this, you see. So this citations here, this is a good thing because like you see, LLMs doesn't do this properly. So if you really want to do this properly, you will need to get the actual source here and just give the output of this to the user. In fact, this is actually a very good output that you can give the user as well. All right, so let's move on. So if let's say you want to see like how the agent has done these the stuff, you can look at the agent status. So you can see the agent name description here and like what are the tasks and so on. So you can see that there are some subtasks that have been completed. First, we have gotten the get knowledge function and the answer, and then we have replied the user in this format. All right. So these are the thoughts that the agent has. And so basically, if you want to see like at each step, what function they use, what are the inputs, you can get it from here. If you want to see what are the outputs for the functions, you can just go to agents.subtasks completed. And this is a dictionary where you can get all the inputs as the keys for the function and the inputs and the output of the function as the values. So it's very, very open. You can just stick whatever you need based on your use case. So if you want to do something like multi-step retrieval, you can do as well. So for example, you want to ask like, how much growth would there be and what are the 3 main areas to capture them? So you can see that, okay, right now, it's defining factors influencing growth. Okay, after that, then it does 3 main areas to capture growth. So over here, it splits the question into 2 parts. All right. Okay, and then it gather all, and then we can output the whole thing in the form of an executive summary. So you can see that, yeah, this is what it has gotten. So yeah, so this is pretty cool. You can do multi-step. This is called Agentic RAG. So you can do multi-step RAG. So if you want it to find out growth in a percentage, okay, maybe you can run this again to find out what's the growth like. I can't remember what's the percentage. I think it's 1%. I think it's 1%. So let's see whether you can find that out. How to calculate percentage. And here we can see, okay, I think it's 5%. Yeah, 5% per year, capturing the next 1 trillion in growth. Okay, so you can see that once we have done this, somehow it's using the formula over here instead of the, yeah, but it got the information is correct. And the 3 things for capturing growth, I think it's also in the source over here. Yeah, so in this case, after I repackage my, sorry, this was not in the source. The source is, okay, it looks like the answer itself has the correct thing. I think it's somewhere in the source over here that says that there are 3 factors to look at. Okay, this is a bit weird. Let's try this again and see how it goes. Okay, I think that the problem is in this query over here. how much will growth be? All right, let's just use this original one. So I think this is great because you can see that there's some real life issues when you use agents. If you specify this wrongly, sometimes the query is interpreted wrongly as well. So you need to add in more layers to do the checks and so on. So this demo is actually not that robust yet, but this is just a way to show like how we can use the agents. So you see the query is now, what's the projected amount of growth in the market for the next year? That's awesome. This is actually what I want it to show. And you can see that yes, the answer here with the sources as well. And then after that, what are the three main areas of growth? And that's great. So it managed to get the three main areas, instant payment offerings, improvement money laundering, and real-time infrastructure and technology. Okay, that's good. And then in the end, we can run in the form of an executive summary. So let's take a look. Cool. All right, so that's it. So essentially, you can just talk to your documents just by using the memory and just use memory.retrieve. You can easily do an agentic RAG like this. Just like 1 or 2 lines to do it. Yeah, it's actually quite simple. All you need to do is to have an agent like this, and you have your agentic RAG. So of course, more work needs to be done to check whether the sources are correct and so on, but this is a very good baseline template already. Feel free to use it. I will be putting it on the AgentJo GitHub. And if you want to test it out with this PDF, you just kindly download it from the McKinsey website yourself. All right, and with that, signing off. And do help to like and start the GitHub for AgentJo. Let me just show you the GitHub. And I hope to grow this. And this should be the best open source agentic framework. And I hope to build it more, to do more multi-agent stuff, to do more memory abstraction spaces, more agent functionalities via wrappers and so on. So you will hear more from me about this soon. And with that, signing out. Bye.